Number 2 in this lab, number 7, says, how are moles, volume, and molarity related? It's important to be very specific when you explain your answer here, and let me show you what I mean. In the concentration virtual lab, I can change the molarity. Here, let me use something other than drink mix. Let me use nickel 2 chloride. I can change the molarity by changing the moles of solute. So in your answer, you need to say the concentration increases or decreases when I increase the amount of moles of solute, okay? But you need to be specific. In another way, you need to also say under what conditions. And here's what I mean by that. I can produce conditions where the concentration, the molarity, does not change even though I'm increasing solute. Here it is. Under this condition right here, you could see I'm increasing the moles of solute, but the concentration, the molarity, is not changing. That's different from the first demonstration that I've done in this video, right? So you have to be specific in your description, okay? What about when I increase the volume of the solution? You see that? Nothing happened, right? Let me do this again. Ooh, now something's happening. So under certain conditions, and you have to describe the condition, when I add to the volume of the solution, something happens to the molarity, and you have to identify, is it increasing or decreasing? Okay, but there is something else when you're dealing with volume, something else that you have to be specific about. When you increase the volume here, are you keeping the moles of solute constant? Here's what I mean by that. Let me drain a little bit. If I use this solution tool, I can increase the volume, but I am also increasing the moles of solute because there's solute inside this dropper, this syringe. So you need to be specific. When you say that you are adding the volume, you need to say, I'm adding the volume, keeping the moles of solute constant, or I'm adding the volume and adding moles of solute. Of course, in science, it's always best to deal with one thing at a time, one detail at a time. If you want to talk about adding volume, you should just add volume, not add solute. You should keep the moles of solute constant, okay? What about when you remove volume, when you decrease the volume? When you explain what happens when you decrease the volume, what happens to the molarity, when you explain that, it's important to be very specific. You should be specific in this way. Are you keeping the moles of solute constant when you decrease the volume? If you use the drain, then you're not. Did you see the green stuff falling out of the drain over there? The green stuff there? You're losing moles of solute, so you're not keeping moles of solute constant. You're dropping the volume and dropping the moles at the same time. In science, of course, it's always preferable to deal with one detail at a time. So if you want to drop the volume and keep the moles of solute constant, you use the evaporation bar. Because when stuff evaporates, only the water or whatever liquid is there, only the solvent leaves. The moles of solute stay the same, okay? And of course, you also need to be specific as to the conditions. For example, here again, I'll make a condition where dropping the volume does nothing to the molarity. So here I go, I'm dropping the volume. You see that? The molarity did not change, okay? I dropped the volume, keeping the moles of solute constant, and still the molarity did not change. So you have to be specific as to what you're keeping constant and what you're not keeping constant, what conditions you're doing it in, and what's happening to the molarity. It's going up or down when you take the volume or the moles up or down. Thank you.